Hello, 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 and welcome back to Algebra 1 class via remote learning. Hope everybody's doing well. Let's continue on in Unit 7. We are on Lesson 4, and it's called Dividing Polynomials by a Monomial. All right? Now, there's something they want to remind you of, and it is called the Quotient Rule. Oh, by the way, if you can hear a weird noise in the background, that's my son using the pressure washer. So apologies if you hear some background noise, but such is life during remote teaching and remote learning, right? You're going to have some background noises. Probably going to hear my dog bark too, right? Because she barks at every bird that flies by the window, so it's part of life. Okay, they want to remind you of something called the quotient rule. The quotient rule is when you're dividing terms and you have the same base, so in this case, like x to the a power divided by x to the b power, really what you're going to do is subtract those exponents. So it's really going to be x to the a minus b. And that's one way that you can do it. Another way that I showed you, and I'll do it up here, would be like this. If you have x to the 7th divide by x to the 3rd, you could do x to the 7 minus 3, which is x to the 4th. Or the other way I kind of showed you or told you to think about this is imagine having 7 x's on top and 3 on bottom, and realize that when you have a term like x divided by itself, that creates a 1, right? Like 5 divided by 5 is 1, or x divided by x is 1. And some of the language I used way back when we were in class together was they cancel each other out. So those would cancel, those would cancel, those would cancel. And what do you have left? Whoops. You have 4 x's, which is really x to the 4th power, right? So no matter how you do it, if you set up the subtraction problem with the exponents, or if you think of 1 on top, 1 on bottom, cancel, 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 what's left behind? 4 x's, where are they? They would be up in the numerator, so it's x to the 4th. Okay, so that's going to come in handy as we're doing these problems today. Again, you know, look how tiny this font is, and I think sometimes these exponents are a little difficult to see clearly because it's kind of blurry here. So I'm probably going to do most of these examples on lined paper. All right? Let's try some. Let's try to divide some polynomials by a monomial. They don't start off too difficult. Hang on, let me get a different color marker. I like different colored markers, you know what I'm saying? All right, example 1. Let's do 36 x to the 5th divide by 4 x to the 3rd. So look at your coefficients. We've got a 36 and a 4. Can you divide a 36 by a 4? Of course you can. And 36 divided by 4 is 9. Now we look at the variables. I've got x5 on top, x3 on bottom. What's 5 minus 3? 2. Or you could say these 3 on bottom would cancel out 3 of these x's on top. So you're still left with x2 on top no matter what. And really, if you really think of it, this is really 9 over 1. If that helps you when you think about dividing by 4, but you certainly don't have to write it that way. I'm most happy if you do this. Final answer, 9x squared. So you're just dividing the coefficients, and then you're just canceling out your variables and exponents. Which is dividing again. Let's do a little bit of a longer one. This is number 3 on this sheet. It's 20a squared b4 c6 divide by 24 a3 b4 c3. So look at your coefficients first. Oh, goodness sakes. I always forget that you guys can't necessarily see what I can see. So 24, A3, B4, C3. That's in the denominator. I look at my coefficients first. Don't judge my fingernails. It's a quarantine. It's a global pandemic, people. I'm doing the best I can over here. Can you divide a 20 and a 24 by anything? Can you make them smaller? In other words, can you simplify that? Sure. You sure can. You could divide them both by 4. So if you divide this by 4 and you divide that by 4, it's going to become a 5 and a 6, right? Now we focus on our variables. A2 on top, A3 on bottom. Ooh, what's 2 minus 3? -1. That would mean anything with a negative exponent would have to be moved down to the denominator to become a positive exponent. Or, if you want to think of it this way, 2 A's on top, 3 A's on bottom, 2 of the A's would cancel, you'd have 1 left over, and where would it be? It would be down here. Either way, you have A to the first power down in the denominator. Whether you set up the subtraction problem, I'll do it here, which would result in an A -1, this is not allowed in the numerator, right? So if you end up with a negative like this, you would move it down to the denominator where it would then become positive. Okay, so that's essentially how it got down there. Okay, so we're done with the A's. Look at the B's. B4, B4, these 4 would cancel those 4, you'd have no B's left. 6 C's on top, 3 C's on bottom. 6 minus 3 is 3, so it's positive, so it would be upstairs in the numerator. Or these 3 would cancel out 3 of those, leaving 3 behind on top. No matter how you think of it, this is your final answer. 5C to the third power over 6A. Okay, let's do another. Oh, let's do this one. 6x plus 9 on top divided by, check this out, 3. So I want to show this because now we have a binomial on top, right? We have the 6x and we have the plus 9. I want you to understand this when it comes to dividing these. Essentially what this means is you have 6x divided by 3 and you have a positive 9 divided by 3. It's almost like 2 separate problems, okay? So even though they only show 1, 3 in the denominator, you're really dividing this piece of the numerator by 3 and then this piece of the numerator also by 3. You gotta spread them out, okay? So now, what is 6 divided by 3? Well, it's 2. And that guy's got an x and this guy doesn't. All right, it just stays 2x. So this is 2x. Okay? And you jump over here, and what's a positive 9 divided by 3? A positive 3. So that's part of your answer, positive 3. So your final answer is 2x plus 3. That's it. Right? Let's do another one. They get longer, so I'm trying to kind of go step by step. Which one let's do 5. 5 says this, 40 x squared minus 8x in the numerator divide by 8. Okay, this time I'm not going to split it up like this. We're just going to kind of leave it as such and see if we can make the division happen. What's 40 divided by 8? It's 5. And x squared just stays x squared because there are no x's down here. Now we jump to the other half. What is a negative 8 divided by 8? Well, that's a negative 1. And that guy's got an x and this guy doesn't, so it just stays x. So there's your answer. 5x squared minus 1x. Or that, 5x squared minus x, right? Remember, you don't always have to show that negative 1 or that 1 coefficient. Let's do a harder one. This is technically number 8. Number 8 says, in the numerator, 10v squared plus 5v minus 15, numerator or in the denominator, just a 5. So we're going to divide, divide, divide. What's 10 divided by 5? 2. And v squared stays v squared. And what's a positive 5 divided by 5? A positive 1. And there's a v, there's no v, so he just comes along for the ride. And what's a negative 15 divided by 5? A negative 3. Final answer. 2v squared plus v minus 3. All right? They get harder. Let's keep going. Let's dial it up a notch. Let's jump. Technically, this is example 11. I know you don't really care about that, but for my sanity and to keep up with what I'm following along with here, I'm going to call that number 11. Here we go. It is a 6. A squared b minus 12a b squared. That's the numerator. And down in the denominator is a negative 2a b. Awesome. Don't look at this and get overwhelmed. It's just step by step. You do your coefficients first. So what's a 6 divided by negative 2? It's a negative 3. A2, A1, well, 2 minus 1 is 1, or this 1a cancels out one of those a's, leaving 1a behind up on top. B divided by b cancels out, nothing left. So you're done with this first term. Now we move on to this piece. What is a negative 12 divided by a negative 2? That is a positive 6. A on top, A on bottom. Those guys cancel, no a's. B2 upstairs, B1 downstairs. 2 minus 1 is 1. Or this one cancels out one of these. Either way, you end up with 1b up in the numerator. So it's negative 3a plus 6b. Let us do another. This is number 13. We have 14 x to the 5th. Wait, is that a 5? Geez, even I can't read it. Good Lord. No, that's a 6. It's x to the 6th. Sorry. Y to the 3rd. Minus 49 x5. I'm sure that one's a 5. Y9 over negative 7 x 4 y. We'll only do a few more after this, maybe two more after this. Here we go. Coefficients. A 14 divided by negative 7 is negative 2. X6 upstairs, x4 downstairs. 6 minus 4 is 2, so you have x2 in the numerator. Y3, y1, 3 minus 1 is 2, y2. Move on, cover that guy up. You now have a negative 49 divided by negative 7. That makes positive 7. X5, x4, 5 minus 4 is 1, so you have x, or x1. Y9, y1, 9 minus 1 is 8, y8. There it is. You just divided a polynomial by a monomial. Very good. Let's say 2 more, okay? Let me pick them though. I kind of want to do some really long, messy ones, like super messy. Let's do it. For my records, this is technically number 20, and it says 28 x5 y4 z3 plus 8 x4 y3 z2 divided by 4 x squared y squared z squared. Cool. Look at how crazy that looks. Doesn't that look intimidating? And it's not. You totally can do this, I promise. Coefficients first. 28 divided by 4. That's a 7. x5, x2. 5 minus 2 is 3. y4, y2. z3, z2. z1. See? Now, do the next piece. A positive 8 divided by 4 is a positive 2 for my coefficient. x4, x2 leaves x2. y3, y2 leaves y1. z2, z2 cancels out completely, and this is your final answer. And that's one of the harder ones. Like, that's one of the sloppier ones. Okay, last one. Last one, I promise. Number 21 says 30, C5, D9, minus 12, C4, D8, plus 3, C3, D7. Holy moly, there's 3 pieces on top. It's a trinomial. What's in the denominator? A 3c squared d squared. I might have to put my answer to all this down below. I'm not sure I've got enough room over there, okay? Okay, so we're going to divide here, and then here, and then here. So 3 separate pieces. 30 divided by 3 is 10. And C5, C2 is C3. D9, D2 is D7. First piece done. Cover it up. A negative 12 divided by 3 is a negative 4. C4, C2 is C2. D8, D2 is D6. Right? I'm obviously doing that simple subtraction in my head pretty quick. Last chunk. A positive 3 divided by a positive 3 is a 1. So you don't really have to show it, but if you want to show it as a positive 1, you can. C3, C2 leaves a C. D7, D2 is D5. Let me check to make sure we did it right. The answer jives just fine. Again, you don't have to show that 1. You could just show plus C, D5 if you want. But whatever, I kind of like to visualize the 1 in 8th grade. I think that's beneficial. Nice job, you guys. I hope it made sense. Don't let it overwhelm you. If it does, I'm literally an email away. You can send me an email. We can set up a Google Meet where I can just do some problems with you one-on-one. That'd be super cool. I completely miss that direct teaching. I miss the feedback. I miss the back and forth between me and you. But, oh well, just going to try to make the most of it, right? So hang in there. You're doing a great job. I'm proud of you guys, and take care.